given this data, let me just expand this data so that it will be visible. Let me increase it. Let me increase this. Let me center it. Now, given this value, this data, we were asked to find the line of best fit of this line. So how to find the line of best fit? The best way to do, I will assume this to be a quadratic equation. So now, but before I make my assumption, I need to plot the graph to see how it is, so that I will know whether it's a quadratic equation or it's a polynomial of order 3. So what I will do now is I will select this. Maybe I can just select the whole of it. Select these plots. So you see, look at the way the data. So the trend of the data, you notice that it's a quadratic equation. You notice the quadratic equation. So now, for me to be able to find the line of best fit of this quadratic equation, I will now use, these are variables. These are not variables, these are constants of a quadratic equation. Let me just say, for instance, let me add, let's say y is equal to ax squared plus bx plus c. That is the general form of a quadratic equation. That is what I'm using. So this is a, this is b, this is c. So a is the coefficient of x squared, b is the coefficient of x, and c is a constant. And c is a constant. So now that is what I will use. So I needed to find the coefficient of a, the coefficient of x squared, which is a, the coefficient of b squared, of x, which is b, the coefficient of a constant, the coefficient of x raised to 0, which is c. So what I will do now is to now look for a predicted value. So I'll just predict a value of y. So predicted value of y, I will now calculate the predicted value of y. I said predicted value will be equal to a. I will fix the a by pressing F4. This fixed now, times x raised to power 2 plus b. I will fix the b by pressing F4 times x, this is x, plus c. I will fix the c by pressing F4. So I will press enter. This is the value for the predicted y. I will now drag down to copy the formula along these lines. So this has been calculated. So what I will do is select this. I can invariably select the whole of this. So select this format painter, select this, it will just format this. So let me just format this too. Now, having done this, let me find the difference. Let me say the difference is d, the difference between the predicted value and y. So it will be equal to y minus predicted value. So this is the difference. Now I'll copy this formula down all through this to this point. I will now format this. Now I needed to get the square of the, that is the square, that is this square. So the square of the will now be equal to this value square, that is raised to power 2. Now copy it down to the end. I'll select this whole thing, format this so that it will be visible. Let me see this. Now I haven't done this. I will now calculate the sum of this value. So I just say sum, press the tab key, select the whole of this, close the comma, press enter. This is the square, the sum of the square, so of the difference. So now let me format it. Now this is what we got. Now, but let me plot the predicted value. Now, what I'm using now to find the best fit to this graph is solver. So I'm using solver. So now I'll go to data tab. I will select solver. Now, if you don't have the solver, you can right click this customize the ribbon. Then now go to add in. Look at the solver here. You just say go. To just go in. It will come here. There is another way you can go from the file. If it's not there in your system, you go to option. Look at the album. You select it here and click go. That's it. It will come here. So now we have it here. So what we'll do, click here. What we'll do now, okay, this place is already selected. Now we needed to minimize the value of this so that so that it will accurately be a best fit to this data. So what I will now do, that is the way to do it. So what I'll do first is to plot the graph of this predicted y. Now to plot it, where the coefficient of x squared is 1, the coefficient of x is 1, the coefficient of the constant is 1. So the values are just 1, 1, 1. So based on this, so here is 1, here is 1, here is 1. So we're using it. We use it to plot the graph now. What we'll do now is we select this, the value of x. We press the control key. We select the value of the predicted y. Okay, no. Let me just select this. Go to data. Go to design. Select data. Now I will now add another series. So the new series I will add, I will just call it the predicted y. By selecting that cell, predicted y. Then here, the series for x values, I will select these ones. These are the series for x value. I'll remove this. Or even if that value is there, let's say you have equal to 1 there. If I select this, what I'll do is to select the whole of this, okay, the predicted value. Then this one is still there, so I'll just remove it, press equal sign. Now I'll press OK. Now we have the predicted value. So I'll now press OK here. So what I will do now is to select this. I haven't selected that. I will go to formats. Now I'll press format selection. It shows up. I'll press this button. Now I need to add the line to this. Now I'll say solid line will be drawn. Now I need to remove the marker, so I will differentiate between the y data, that is the true y data from the predicted y data. So I will select this, select none, so the predicted y marker has been erased. So so this is the way it is now. You have this. Now let me select this again. I need to select format selection. So what I need to change the color of the line. Sorry, I need to change the color of the line to red, so it will show a difference, because the actual data has a blue dotted line. Then the one I want to show, if the one that I want to use to get to know whether it's the best fit, the line of best fit. So now this line, if you check this line, is not line of best fit. So to be able to get it, to make it line of best fit, and when you check the difference, is very high. So I need the difference to be 0 or even minimal. So but it has a very high value. So when you check the difference, there are great difference here. That was why we have very large value here. So now if I use a solver to make it possible, so that this difference will not be minimal, will not be so small, so that the sum will be at a minimal value. So now I'll go to data, I'll select solver. So I will select option here, minimal. I set this object here minimal, so to minimize it. Then now I will select the values I needed to be changing. These values should be changing in order for this to happen, in order for this to be minimized. So I needed to get the coefficient of x squared, coefficient of x, and coefficient of x raised to power 0. So now I needed, this is a non-linear equation, and let me solve. Let me now see how the trend will go. The line will move and get to that place as the thing is solving. See, the thing just moves straight into that place and fits directly into the line, perfectly into the line. So this is the line of best fit, and these are the values. Now let me see more values by clicking this. So these are more values of this. So these are as in higher precision of 0.000. So it's 4 zeros. Okay. Now if you're given these values, like now this is time, this is moisture ratio of corn. This is the moisture ratio of corn. Let me delete this graph plotted here. This is moisture ratio of corn. What for me to plot this graph, I needed to find the equation of line of best fit. I need to find the equation of the line of best fit. So the formula we use to do that is just to say a. Okay, I've used a in one of those equations, those sheets. So now I'll use a, b, and c variables. So I will use d x times exponential minus k t. This is a drawing equation. So this is a drawing constant. This k is the drawing constant. So now this is also a constant d. This is E is 2.718. Approximately 2.718. Yeah. Now raised to power minus k times the time in minutes. So let's go back to the data. Now what we do, we plot this data. Let me just use let me use this. Sorry, let me click it. Let me open this. Click new. Select this. Select edit, copy. Minimize this. Snipe window. Just paste it here. Just let me paste it here. This is the formula we're going to use to find the line of best fit. So we need to find this variable. These two variables will have d and the drawing constant k. So first, we need to plot the graph of this data given. To do that, I will just say insert. I'll go to insert under charts. Under charts, I will select this. I will select the scattered diagram. Select the scattered diagram. Then this is how the graph is shown to be. So is now the moisture ratio from 1, it begins to decrease till it gets to a point, it becomes constant. It doesn't change. So no matter how you draw it, the moisture content will remain constant. So at that point you stop. So this is the minimum amount of moisture content that will remain in the sample. If you try to dry it further, you burn the corn. The corn will be completely burnt. So if you try to completely take off the moisture content, you dry you destroy the corn. So now let's find the equation of the line of best fit. So now we are going to use this drying equation, this kind of drying equation. This look like paper model. Sorry, like paste model. Okay. Page model. This look like page or paste. Yeah, like page model. So we're going to use it. So now we're going to calculate the predicted value. The predicted value of MR. Now the predicted value of MR will now be equal to. Now before we start, let's say here is D and here is K. Now we have the values as 1 and here is 1. Now let's select the whole of this and name this cell. This cell that the values are 1 1. So I'll go to formula. I will select create from selection, left column correct. So click. So we have created D and K as equal to 1 equal to this cell. D is equal to cell K3 and K is equal to cell K4. Now if you select here, you notice that the name of the cell, essentially the name of the box is D. Here the name of the box is K. So we'll now use these variables, these constants, to find the predicted value of MR. So I will now say this is equal to D, which is that cell, times exponential, press the tab key, minus K, which is that, times time. Now the time, we did not create time, so what will I do now? Let me just say 1. Let me use 1 there. But here I will need to create this. I will just say define name, make it, I'll say T, say okay, so it has been defined. So what I'll do now is to change this. Now to change this, use in formula, I'll just use in formula, I'll use T in formula. So I'll just select that T there, I'll say okay. Now I will copy down the formula down to this place. So this is it. So I needed to calculate the difference D. Let me center this. Press the center button. The center button can be Ctrl E. As if you use Ctrl E, you can center something. Let me just do that. Let me say press Ctrl E. Now if I say Ctrl E, okay, sorry. Now let's calculate the difference. The difference should be equal to B2 minus C2. Now let's come down to this. Let me copy this down. Let's calculate the sum of, okay, what is the sum of the difference? This one now. I need to calculate the square. That is D raised to power 2. The value of D raised to power 2, I'll just say this is equal to D raised to power 2. Now copy down here. I needed to calculate the sum of this whole value here. Bracket close, enter. So I've gotten this, which is the sum of the square of the, which is the square of the difference. Now, but I needed to plot the predicted MR. So let me select this graph. select the design, select select what I will now select from the data panel. I will select data button. So here I will select the add button. So I'll select the predicted value, the predicted MR cell, which is C1. That will be equal to the predicted MR. So series X value is this time value. Now I will now select the predicted MR value. Press OK. Press OK. Now we just say OK. I need to select this. Select the format. Say format selection. I was now needed to add a line. The marker I will remove. Okay, no, not the marker. Oh, no. This the field should be there. The marker I will remove it. Now this is what we have. Now this is the data, the actual data. Then this is the predicted value of MR, the predicted value using this formula stated down here. So we needed to use solver. Let me just go to data solver. Okay, we need to select this point, minimize it. We now need to make change between this and this, between this value and this value. We need to be changing this value so that this graph, let me just bring it like this so that we'll be seeing. Okay, let me just delete this. Let me move the charts away a little. Now let me bring the solver dialog box again. Now we should be looking at this as this one is changing. We have this, which is what? E13. Now we have K3 to K4, which is this to this, correct? Now that is the variables we're going to be changing. We're going to be changing these variables. This one, this two, this one. So the Excel spreadsheet will be making the changes for us till we'll get the best line of the best equation that is the best line of fit, that the best define this data. So I'll create solve. So okay, see, this is the value of D and the value of K. This is the value that best defines this. This value is minimized. Now I needed to minimize this so that the difference between the actual and the predicted value will be minimal in order to get the line of best fit and the equation of the line of best fit. So the equation now, we have gotten D to be 1.04 E raised to power minus 0.017476 times time in minutes. So we haven't gotten this. which this now gives us the line of best fit. So what I can say now, please subscribe to my channel if you like this video, press the notification bell, and help me to share the video. Thank you.